this unit called?
Probability.
It just told you. Mm-hmm. The probability. The probability of whatever's in the parentheses happening. You might need to watch some videos of the lesson you missed, huh?
I'm on this one.
I forgot to yesterday, I was outside over there.
I'll take him driving.
Did you pass? Really? You didn't sound real. You're.
He sent me a picture
The
of it.
picture looks really bad.
Oh, yeah.
Usually, at least you got it.
I was doing something, so we were looking at cars.
Yeah.
All right, you got it. If you quit looking at your phone as much, you can get it faster. I'm just picking on you today, aren't I?
Don't we always?
We'll talk about that when we get there, what it means. Because both of those, the second one and the third one, are both say or. So the probability of this happening or the probability of that happening. But if one of them depends on the other or not, you gotta take that into account. So we'll talk about that. So when we did, see, today's Thursday, so Tuesday when we did probability, it was just a probability of one event. So you just had probability of A or whatever it was. So now the first one, we're just gonna work through an example or two of each of those different types. So the first one says and, so that means that they both have to happen. So we need to remember to multiply, find the individual probabilities and multiply. Then the other two that's got or, it's addition, but we gotta learn about what mutually exclusive means when we get to that. Okay, so let's get a new page here. Where's my thingy, my bopper? Come on. There it goes. I'm lagging a little bit today. Not like me, I was tired this morning. Okay, so let's say we're at a picnic and we got 10 diet drinks. So I'm just gonna make some notes of what we got as we go. So there are 10 diet drinks and 5 regular drinks in the cooler. There are also 8 bags of fat-free chips and 12 bags of regular chips. You're gonna grab a drink and, so see there's your and word, you're gonna grab a drink and a bag of chips without looking. What's the probability that you will grab a diet drink and fat-free chips? Okay, so let's just do the diet drink first. So what's the probability of getting a diet drink?
10 out of 15.
10 out of 15.
2/3.
Okay, so that'd take a 5 out of that, and that would be 2/3. And multiplies. So what's the probability of getting fat-free chips?
2 out of 5.
Well, what did it start off of since I put the first one up here?
8 out of 20.
8 out of 20, and then take a 4 out of that, and you get the 2/5 that Christian said. So it's an and. So we multiply across the top, multiply across the bottom. That doesn't reduce. So the probability of getting a diet drink and fat-free chips is 4 out of 15.
Yes, sir.
Yeah, that's it. You would be about almost 27% if you wanted to put it as a percentage.
That's easy.
Yeah. Okay, so we're gonna get into the, do we need to try another one of those? Y'all pretty, you do wanna try another one? Let's go the other way then. Let's mix them up. Let me erase this so I can use the same cooler and bags of chips. Let's say we wanna get probability of getting a regular drink and fat-free chips. So what is the probability of getting a regular drink?
5/15.
1/3.
5/15, which is 1/3. What's the probability of getting fat-free chips?
8/20.
8/20ths, or
11/15.
what? What's 8/20ths reduced to? You did it a second ago.
2/5.
2/5. Multiply, and that is 2/15. Where did you get 11, or were you just saying numbers like you normally do?
I was doing the opposite of what the other one was.
Well, I thought about doing that, and that is what that would've been right, but I didn't make it the opposite, I made it,
Yeah.
I mixed them up. Okay, so let's talk now about that mutually exclusive, what something is if it's mutually exclusive. So basically, two events that can happen at the same time are mutually exclusive events, because let's say, for example, you roll a normal dice. Could you roll one dice and roll a 2 and a 3?
No.
No, you can't, it can't land on 2 and 3 at the same time, right?
Unless you roll a 5. Then it's 2.
Well,
Dude,
no,
yeah,
no,
you're
no,
wrong.
no, no.
Or 6.
So that would mean, since it can't happen at the same time, that would mean they're mutually exclusive. Okay, so can we roll that same one dice and it be an even number and a multiple of 3?
Yes.
What?
6.
7.
So that would not be mutually exclusive, because it could be either one. Okay, so the difference here on our mutually exclusive and our not mutually exclusive is if it's not mutually exclusive, you gotta subtract the overlapping ones out. That's what that minus piece is up there. So let's get a clean sheet and go try some of those. Alright, let's say it's your high school. A student can take one foreign language each term. About 37% of the students are in Spanish. 15% take French. Where'd my marker go? 15% French. And 15, I already did that one. What's the probability that a student chosen at random is taking Spanish or French? Okay, so first off, one thing that I read to you, I said at your high school, a student can take one foreign language each semester. So could a student be in both of those in one semester?
No.
No, so we do not need to subtract anything off, okay? So we're good on that. So that means they're mutually exclusive. So what's the probability of a student being in Spanish?
37%.
37%. I'm gonna put that as 0.37, that'll make it, I don't know, I just want to. Now, or, what did it do after the probability of the first one? Add, subtract, multiply, divide? What did the formula do on an or?
Add
Add. And then what's the probability of a student being in French?
0.15.
0.15, so we add that up. 2, 4, 5, 0.52. 52% chance that a student's in one of those classes. Easy schmeezy. What you're gonna have to just be careful about is remembering which ones you add on and which ones you multiply on. Okay? Alright, well, let's say, I gotta draw a picture for this one.
Is the mutually exclusive thing like if it did a Venn diagram where it meets?
So if there's anything in the overlapping part, very good thinking there. That's one of the examples that I saw when I was looking this up. Alright, we got a dish of just random tokens. I'm not gonna draw it all, because that would take me forever. I'm gonna write what's on the dish. There are 2 green circles. There is 1 green square. There are 2 red circles. There is 1 red square. There is 1 orange circle. There is 1 orange square. Okay, so it says, suppose you reach into the dish and select a token at random. What's the probability that the token is round or green? So that one, since I wrote circle, probability that it is circle
Four circles.
or
Three,
green.
7.
Okay, so let's look at this. Do you think we could perhaps put this on a Venn diagram of sorts, Christian? Do you think we could perhaps put this on a Venn diagram? Do you wanna try? Okay. Let's see, what do we got? 1, 2, wanna do, that's gonna have to have a lot of circles for, never mind, Christian. That'd be a difficult Venn diagram to make. Okay, sorry, Holly. So first off, what's the probability that you're a circle? So count,
5
right
out
here
of
you
9.
got 2 on the 2 greens, so 2
5
two
out of
reds, 4. Here's a 5, so you got 5 out of,
9.
how many are total tokens? 2, 3, 4, 5, 6, 7, 8, 9, so 5 knights. Then I see the or, so I add. What's the probability that I'm green? So I'm just looking only at greens. 1, 2, 3. So 3 out of 9. Now, can I be both a circle and green? Yes. So what we did there, if you can be both, you have to subtract that off. So how many are circles and greens?
2.
2 out of 9. Okay, see what we're doing there? So 5 knights plus 3 knights is 8 knights. And 8 minus 2, 6 knights, also known as
24, 30 seconds.
Why would you go that way?
2 seconds.
I mean 24 36s, not seconds.
Yeah.
Christian and his negative 0 to the 1 equals 4.
You
So
wrote that.
That one's
off.
mine. Yeah,
Jesus,
I'm proud of that
dude.
one. Most of the others are
7 times 7 equals 14.
that one makes sense. 6 was mine.
Christian, something's wrong with your brain over there.
That's what it said. Really like it.
Alright, so do you think,
No.
Christian, you gotta hear the
Oh,
question.
that's dumb.
Do you think you can do an assignment on that tomorrow?
Yeah, yeah.
You?
Yeah, tomorrow.
Probably. Alright, then that's the plan.
Stay.
And what it's looking like, and this is not concreted yet, but a lot of people, it's in the year and a lot of people are asking what it's looking like is we'll have an assignment tomorrow, and then next week, Monday, Tuesday, and Thursday, we will have notes, and then an assignment on Friday, and that'll be our last grade.
Yeah, yeah.
So it's not looking like we're gonna get everything done for a test.
I won't be here tomorrow.
Oh.
That'll be fun.
Just have to, sorry Zach, just have to get it made up.
I'm real looking forward to that.
I'll have
I've
to
got
get,
some people that are wanting a test because they're wanting a grade bringer upper. So I'm just telling them they better make 100 on both of those Friday assignments.
Make those assignments work.
I can't remember, I think it's got a front and a back page, so there are a lot of points.